Okay, shall we start? Let's go to the detail and let's check the class schedule. Class schedule. Today is October 22nd. So we will discuss database, which is one of the tricky topic in this course. So I found this attendance of this class, today's class, has a high correlation with your final grade. Yeah. So you made good decision. So stay until the end and pay full attention. And I posted your midterm mark. You did very well. I'm very pleased with the results. Class average was 86%, so which is, I think, this is the best I ever seen. So I do not worry that much about whether you fail or not. So, but this class and the midterm 2 is quite determinant of your final grade, right? So keep working well. And today is due of assignment 4. So let's see assignment 4. Let me see. This is assignment 4. Is it? Is it? Assignment 4. Assignment 4 is due before the beginning of the class. So says, how's it? Molly, Jane, Dylan, Chelsea, Jared, Wing Yu, yeah, Fafta, and Matthew, Luke, Zeus, and Heather, Nathan, Haley. You got 1 choco point. Not many people submit assignments, so I wait until midnight, so please finish it. Anyway, the on-time submission, those who submit on time, you got 1 choco point. And again, next class due is assignment 5. Assignment 5 is based on today's class. And also we will have guest speaker, Mr. Dave Gamble, who is director in the finance transformation in JD Irving. So it's rare chance to meet executive level guest speaker. He will talk about how information technology is used in finance department in JD Irving. So please come on time because they executive usually come earlier than their usual time. So come 5 minutes early so we can start right away. And install NIME. Maybe from next week we will use NIME Nime is a very nice tool. It's free, so you can keep it. Once you install it, you can keep it even after the class. It's very nice to do business analytics. So you can clean data, visualize data, analyze data without knowing any programming language. So install it and expect it from next class. So let's go and get into today's topic. Today's topic is database. Database. So far, we discussed managerial topic. So basic question, where should we apply information technology? We reviewed several area which has a good impact on having applying information technology. So we discussed generative AI and high static value chain activity, increasing switching cost, entry barrier. That area is key area. You need to employ computer, and bigger benefit come from enterprise system, integrating, sharing information through whole enterprise. That's what we discussed so far. Today, we'll discuss quite technical topic, database. Why do I discuss database? Because it's key enabling software for enterprise system like CRM, ERP. And also, in the very small organization, very small one people, two people startup, you will use Microsoft Excel to store the data. But if your data grow, it become bigger data, you need database, and you need to cannot handle data using Microsoft Excel. So this is technology collects data and share data in effective fashion, much more efficient than Microsoft Excel. And also, it is not likely you will create a database by yourself, but your company IT group will create a database. But your role is as a manager, you can extract data from database and then do the analysis. Yes. Oh yeah, the question is, can you download that PPT? Yes, PPT is, let me see. PPT is in the database. Go to the lecture slide. And 4-1. 4-1 is database lecture slide. So if you wish, you can download and watch it together. Good question. You got 1 choco point. And another reason, so if you know the database, then it's much easier. You can extract data from company's database. And the other reason is accounting profession. CPA organization explicitly asked me include the information system development process. So how information system is developed. So accountants need this knowledge. So I teach database design, so that teach information system development process using database. So that's the reason. And as I told before, your final grade usually depends on this course topic, and this based on assignment and exam. So pay attention. And also, if you need any question, if you feel free, stop the class, raise your hand. It's like a math. So first part is building block for next part and next part. So don't wait until the end. just raise your hand and stop the class and feel free to ask a question. Okay? So change your mode to tackle dry topic. Change your brain mode. So 3 parts I will discuss today. First part is database concept. So what is the database? Second part is relational database, which is most popular database. Then third, I will teach you how to design database. Okay. Many companies use, but in case of small company, those who do not use database, they use file to store data. Here, file means usually Microsoft Excel or spreadsheet to collect data. So spreadsheet data or Microsoft Excel data was used to store data. But if your company grow, it create a problem just using spreadsheet. So let's trying to figure out what's the problem. Keep using this Excel store data. So here is the scenario. Let's assume we are university, and university has 3 departments. First department is registrar office. Registrar office maintain student information, course information, and instructor information, right? And there is another department, parking department, maintain student file, and they handle those parking issues, the parking pass. Housing department manage dormitory, so they have also student file and dormitory file, in Excel file, in spreadsheet. Now let's focus on this file part, right? They are using, each department use their own student file as an Excel file. It can be a problematic. It can be a problem because each department maintains its own student file. Let me give you an example. Let's assume you are president of that university. You ask this question: how many students do we have? Ask to 3 directors in each department. Then each 3 director will get information from their own student file. So registrar office say, oh, we have 1,003 students. Parking department says we have 950 students. And parking department says, oh, we have 970 students. If you are president, would you believe this data? No, right? 3 director says 3 different number. That's the problem, maintaining separate student file. Unless strong synchronization process, then their file tend to be inconsistent each other. So maintaining separate spreadsheets for each department creates 2 problems. First problem, most important problem, is data integrity problem. So the data is inconsistent. Total number of students different. So we cannot believe this data. Another one is data redundancy, duplication of data. It's waste of storage space and waste of effort. So the university president upset with this situation and asked 3 director, fix this problem. So 3 director get together. Okay, why don't you just use one Excel spreadsheet one file, then we will give same answer, same answer. When president asks how many students, they will give same number. Can you see any problem in this part? If we use just one Excel file across all departments, anybody want to suggest one choco point? Anybody? Yeah.
If the problem being one chart across all of them,
Mhm.
is that if one person makes a mistake on it, then it throws off every.
Yeah, yeah, because it's centralized. One person type wrong data. It is all wrong data. Good, one choco point. Anybody else? Okay. Do you think housing department now see your GPA and they can change your GPA? Would you accept this? If they change it to F to A, that's okay. But if they change your grade A to F, it's unacceptable. So there is a security issue. Because you share one spreadsheet file and every step here can see. So it's not good. So if you use shared file approach, it has security issue. And also battery is not good. Security issue. And there's another issue, which is technical issue, maintenance issue. I will explain it now. To use a file in the program, and not just people, there is a program. You write a program for register office, parking, and housing department. This program want to use student file, then you need some kind of file description. That simply tells to the program what's the layout of the file. For example, this student file, first 9 digits is student number, next 11 digits is last name, 9 digits first name. Similar to this statement should be included in the program to use that file. Okay. So what's the big deal? If one student file is used in the 3 department and there is a programs, then each program needs this file description. This blue part is showing layout of this student file. Now here is a scenario. Let's assume a housing department wants to add a rent field to this student file, student file. Then housing department need to change this one naturally because they want to use this program. But by adding rent department, the register office do not use this field. Parking information system do not use this field. But nonetheless, they have to change this program. How many programs they have to change? In this picture, 6 more, right? But in actual department, each department has hundreds or thousands of programs. So you have to change that many programs. Changing itself is simple. You're just adding one line. However, once you change the program, you have to test it, whether it works okay with other programs. So it gives huge workload. So if you share the program and there is a new field come and you do not use that field, still you need to change the program. So it's huge maintenance work. That's the 2 problem if you use one shared file. And database solve all these problem. Database conceptually shared file approach. Store all the data in one place. So there is no issue of data redundancy or data integrity. It's all consistent. But difference is it has middlemen, so-called data management system or data management software. So you need to use database software, which is example is Oracle, IBM DB2, SQL Server, MySQL, all these are database name, and you need one of these. And before this register office program read data directly student table, right? But now it's different. Whenever you wanna read the student file, you have to ask to database system, then database will retrieve data and return it. So system is there is a middleman managing your data. That's the conceptual structure. So now let's see how this database can solve those two problems. First one is security problem. Security problem is solved by database. Database's function create logical view. Logical view is the database view, which is shown, which is from the programmer's point of view. Database looks like this one. Actual database. This is actual database, has many other components, moon and palm tree and wave. But you can create a logical view for register office so that they can only see this moon. So they cannot see any other view. As a result, you can effectively ensure security. So parking staff cannot see your GPA anymore or update anymore. So security is solved by separating logical view and physical view. And second problem was maintenance issue that happened because file description is embedded in each program, right? But now file description is outside of each program and it's maintained by database software. So if you add rent field here, rent, you need to change the layout only once before you have to change thousands of programs. So that's the benefit of using database. Database consists of 5 components. First one is database engine, which is the one actually retrieve data, store data to the database. And most databases data definition subsystem, which from there you can define logical structure of data. So you will learn how to design logical structure later. And then you need to retrieve data, right? That's from the data manipulation function. And most modern database include application generation function, meaning by a few clicks, you can make a data entry screen and menu to retrieve data. So without knowing programming, you still can make a simple inquiry program or data entry screen and create some report. Database is designed by many users, almost all companies user. So data administration function should be very strong. For example, backup and recovery. What if it is centralized, right? And there is a power failure, electricity gone. then most case your Excel data will has damage, right? But database has a system to recover this damage. So you will not lose any transaction using database. Okay. Plus these 5 functions is included in database. In terms of how data is organized, there are 4 types. First one is hierarchical database. It's developed around 70s. First, information is divided in small segments, and we organize this data using hierarchical structure or tree structure. This data is splitted and organized this tree structure. And we read into from top to bottom. This is efficient, but if you want to read to right to left, it's very slow. So another one is the network structure. You can, in that case, organize data, not tree structure, but network. So you just connect everything with pointers, so you can access each segment quickly. This was first 2 database, but 80s there is a relational database was developed, and it become big hit. Very popular. This one is save data in 2-dimensional table, like spreadsheet. 2-dimensional table, so it's easy to understand, easy to use. So now most company, about over 90% of company use relational database. Relational database is kind of de facto standard. So this one is very strong, store structured data like order, inventory, or invoice, kind of structured data, but weak for unstructured data like document, image, movie. You need some special database. And also it's weak in terms of semantics. It has a field name like sales, then we don't know what's the real meaning, how they calculate. So this is, and another one is these days no SQL database. To read this relational database, you need structured query language or SQL. Sometimes people do not like it. It's difficult to learn. So there is some no SQL database, which do not require structured query language to access it. Or sometimes these days, speed is important. So we use in-memory computing. Instead of saving data in the hard disk, we process all the data in memory, so give the real-time result. So those new database come. However, most important, over 90% of data is stored in relational database. So let's see the current trend. So top database. So if you click this link, you can go this website and you can see the popularity of this engine. So first of all, let's see the top 6 popularity: Oracle, MySQL, SQL Server, or top 6 relational database. And in terms of the current ranking, Oracle, MySQL, SQL Server, these 5 are all the RDB, relational database. And MongoDB is non-relational, so it's no SQL. If you do not want to learn SQL, use MongoDB. And Redis is kind of in-memory computing. You don't have to memorize it, just so in-memory database become popular. Snowflake is cloud-based database. So these new type of database coming in and getting sometimes use it, but still most company and majority of data is in relational database. So relational database store data in table structure, and they are de facto standard. That's the conceptual explanation about database. Any questions so far? No? Okay, let's do some tests so that you can summarize or remember longer. So make a 2 or 3 people group and let's play game. Okay, so 3 together and 2 together, 2 together, 3 together, 2 together, and 3 together. 2 together, 2 together. So each group, one of you log in. 1, 2, 3, 4, 5, 6, 7, 8, 9 groups. So everyone get 1 choco point, and those top 5 group will get extra 1 choco point. So shall we continue? Any group need more time? Okay, so it's team mode. Integration issue. Inconsistency happen if every department maintain their own data, right? Yeah, if you use same file, each department program include the file description or file layout, and file layout is changed by another department. You have to change that file as well, your program as well.
你选哪个？是绿的吧？感觉不像黄的呢。
啊，
蓝的。
KDM, congratulations. SNH, congratulations. LA, good. And let's see the other number 4 and number 5. So number 4 is Jaja. Yeah, thank you. And IT, congratulations. So those top 5 got 1 extra choco, and everyone got 1 choco. So now we will change the topic. Now we will talk about relational database because it's most popular one. Okay. So in case of relational database, data is organized in two-dimensional table, like this one, similar to Excel, right? Database looks like similar to Excel. And the first row is about column heading or the field name. So first, this kind of sheet is called table or relation. Relation is original name, but most people call as a table. And each row in the table is called tuple or record. Each column is called attribute or field. In this table, how many attributes can you find? 5 attributes, right? 1 ID, last name, first name, hours, and race. So there is a 5 field or 5 attributes. How many records this table show? The first row is the field name. So actually it's 4. 4 records. 4 records. And now each table should have a key. key, or we call it primary key. This is very important concept. I'll explain further. You actually use key. Key is used with that value. You can retrieve single record, one record. For example, if you visit registrar office, student service office, they always ask your information. What do they ask? Student number, right? That student number is key to retrieve your record. If you visit bank, what do they ask? Your bank card account number. Account number is key to retrieve your record. If you visit Service New Brunswick, they will ask your security insurance number or driver license number. They are all key. With that value, they can retrieve your record. That's the key, and relational database need the key. I'll explain this one a little bit later more, and we will practice this primary key part. But another restriction of this relational database is each cell contains only one value. For example, this is hourly rate, and you cannot enter two values in one cell. That's same as Microsoft Excel. You cannot save two values, right? That's the restriction. Multiple value. Now let's talk about key. To be a primary key, there is a three condition. One, field should be unique, right? There should be no duplication. For example, your student number is same as your student number. Then what will happen? All your record is mixed up, right? So to be a primary key, value should be unique or no duplication. And second time, field value should not change over the time. Field value should not change over the time. Imagine your student number change every day. Can you keep track of that? It's terrible, right? So it should not change over the time. And if it's unique and do not change over the time, then there are many candidates, then shorter one is better in terms of length. Length is short, then it occupies smaller size of memory, so it's much efficient. So remember these three criteria. Now let's apply this criteria, and let's see this example. There is a table. So there is a table. Let's check whether each one can be a primary key. So let's see the furnished field or furnished attribute. Can it be a primary key? No. Or why not? So it's duplicate, right? There are several Y. So it's duplicate. So you cannot be a primary key. How about number of bedroom? No. Again, three duplicates. So we don't know which record we can retrieve. So it's not good for primary key. How about type? Type also there are AA. So there is a duplication. So it's not good. Value should be unique. How about room number? If you pay attention, there is a 100, 100. So it's not good. How about building number? No. So no single field is good for primary key. Right. This is dormitory table. So there is a 3 building of dormitory, and each building has a room number. So now let's combine these two, building number and room number. Can it be a primary key? Yeah, I think its now value is unique, and it is unlikely to change over the time. So there, in that case, write down P. Can you write down P above this column? Meaning this is primary key. And this kind of primary key, which consists of 2 fields or 3 fields, we call this composite primary key. Composite primary key. So now there is a 3 table. One table is about truck, and another table is about base parking station, and another table is truck type. There are 3 tables. Can you identify primary key? For example, if truck number is primary key, write P above this field. And each table needs only 1 primary key. If there are 2 more candidates, then apply these 3 rules. No duplication, do not change over the time, and shorter one is better in terms of events. So you can discuss with your group and compare your results. And I will check individual because this is very important part. So show me primary key. You can discuss with your group. And write down P above that primary key. For example, if it is strong number is primary key, then write P above there. Look, don't try to write here. Don't try to write here. Write P above the field heading. Field heading. Do not trying to write here, but above the field and attribute, write P. So let me show me. There are 3 tables, and each one is find here. Depends on it can be from and check the base table and check whether it is primary or not. That one is based on 3 some. Short ones together and discuss. Yeah.
Oh, by, It's a good, it's catchy.
This is three tables. Each table will be one primary. And this one apply the first condition, notification. And second, it does not change over time. So when you see it's not hypo notification, but the meaning your mind means whenever job, right? They will tweet. So in the second one, there's a second one. This is not an ideal thing. 5-8. This is potentially same day as so this is the only one can be a good.
So if this one wasn't here, would we combine this?
Maybe.
You ever seen?
Combine still would show simplification. Because I explained this one, but yeah, this is not quite like different, but the previous.
Right.
So let me check the last. Let me ask a question. So let's do it together again. So let's do from the beginning. Yeah. How about truck by date? Can it be a primary key? No, why not? It's duplicate. So potentially we can buy truck in the same date. So there is a duplication. So it's not, it can be a primary key. How about truck mile? Truck mile looks unique or no duplication, right?
But they're subject change and they couldn't they end up being the same?
Right. So, but in the second condition is it should not change over the time, but truck mileage will change whenever truck drive. This value change, so it's not good for candidate for primary key. How about type code? Duplication, so it's not good. Base code also has a duplication, right? 501, so it's not good. So truck number is no duplication. Truck number is no duplication. So we choose truck number as a primary key. Now let's go to the base code part. How about base manager? Base manager, one manager can manage several parking space, so it's not good. So base phone number, also several parking stations share same phone number. I think same phone number here. So this is not good. In case of area code also, if in same area, you can have several parking spaces. So if there is a potential duplication, you cannot use it as a primary. Base state, one state can have many parking stations, so it's not good. Base city as well, one city has many parking. And base code has no duplication. So we choose P as a base code. Primary key for base code. Now let's go to the type table. Description, duplication. Description 1 also has a duplication. And type code has no duplication. As a result, we will use primary key, base code, type code. In real case, most time we create artificial primary key to ensure no duplication and do not change over the time. And also if you artificially make it, then it can be a short. So that's the reason we use strong number, code, base code, type code, this kind of artificial field to assign unique value. So your student number also artificial. Now, once you identify primary key, is it clear? Anybody has any question? This is most important concept. Okay. Then identify whether this primary key is used in other table. So is it strong number used in other table? No. Okay. How about base code? Is base code used in the other table? Yes. Where? Yeah, truck table, right? So then this base code in truck table is foreign key. Then is type code used in other table? Where? Yeah, so this type code is in truck table is foreign key. Foreign key is field in a table used as a primary key in other table or other tables primary key. Can you identify foreign key? Let's practice. Foreign key definition is here. Field of table which is used as a primary key in other table. So other table's primary key is used in this table, then that field is a foreign key. So let's practice. So here is a foreign key, and there is another table. If you turn the page, I think there is a two table, department table, and employee table. So this is department table, employee table. So for each table, find the primary key and write P above each attribute, the key field. Then identify foreign key if there is any. First, primary key and write P and check whether that primary key is used in other tables, and that field is and you can compare your result with your group, and I will check individually. So you can discuss, feel free to talk. First of all, find the primary key. Which field has a unique value and do not change over the time, and which one is short? These three conditions. Apply three conditions and find the best one as a primary key. Diving primarily and then so going. Which one is primary? This here is so that so there is can be a primary, right? The names but the idea also can be a primary. It's unique and does not change over time. And between two, which one is short? And that one is. So apply three conditions. Then you Between two, which one? Both. Not change your whole time. Also. Will you choose one? Yeah.
Sorry, it shows we've got one. It's either two different.
Well, I think most of you get an idea. So in case of department table, DID is primary key, but in the department table is a little tricky because there is a name, department name usually do not change, and DID also do not change. So first condition is met by these two, and second condition also. Then between these two, which one is primary? Apply third one, shorter one is better. So in terms of length, this is 1 digit, this is several digit. So DID is primary. And in case of this time, last name looks like no duplication, but if your common sense tells you there are so many people has same last name, right? Do you know my last name is Kim? In Korea, about 13 million people's last name is Kim. So you can tell I am from very strong, energetic family. Okay, so many people, the last name, so first name as well. There is a potentially duplication, so it's not good for primary key, so EID is primary key. Once you identify primary key, then find this field. DID is used in the other table. Then that DID is used here, right? That one is foreign key. And is EID used in other table? No, then there is a no more foreign key. Let's practice one more time. This time, 3 tables. Customer table, book table, and purchase table. So identify primary key of each table and identify foreign key if there is any. And so write P and F. And you can discuss with your group. If you need help, raise your hand.
No.
First of all, this table has we have 2 primary keys, just one. Which one? Number? Then find the customer number is used in other table. Then add it foreign key. So foreign key is other table is primary. And book code used in the table. Then this is no foreign key of purchase.
So there are 2
Yeah. Yeah, only one primary key, one table. So there are 3 tables. Each table has a primary key, primary. Once you identify primary keys, then when the primary is used in the table as a bill. So this is foreign key of this one. So this is foreign key. So there are 2 things.
Did you guys get that? No, you don't. He was
I think we were just spraying.
So let's see your so then identify foreign keys. Foreign keys. Other tables. Another way is customer number is used as a foreign key of purchase. So this book then this is so foreign key is other tables which is used to the primary key in other tables. Order number used in other table. No, then there is no more. The definition is
24.
So we can do
other tables.
usually.
But when you check you go, it was primary key.
Machine by.
This is going,
Yes.
correct. So let me.
You want milk? You want- I'm not sure it's the Jane. I can't believe you guys didn't come here. It's the top. Is it? Yeah. Yeah. We select that.
Now you understand what is the primary key and foreign key, right? So now trying to read this data, let's go back to previous slide. Here, primary key, foreign key. Can you tell me, can you find the Alex Irving? Alex Irving? Alex Irving. What department Alex Irving is working for? Finance. How did you know that? Yeah, foreign key has a 2. So you bring this value and go to the department table and get the finance. Let's practice one more time. How about Robert Killam? Robert Killam. What department is this guy working for? Can you find Killam robot department? MIS. How did you know that? You get the foreign key value and go to this department table and search the primary key and find for and get the MIS. Correct? That's what exactly relational database search this data. So let's try this 3-table case. Tell me, there is a Polos, customer Polos. Can you tell me the book title that Polos purchased?
Bright Star.
Correct. So how did you get it? So you find 111 and go to the customer name 100, 100. So this using book code, go to this part and it's Blazing Sun. And BA38 is Bright Star. If you utilize this way, now you can read relational database. So what's the relational database is? After all, very similar to spreadsheet, Microsoft Excel. What's the difference? Originally, its spreadsheet is designed for individual use, but database is designed for whole companies. As a result, can include many big data, but the spreadsheet is limited 1 million records. And you can describe complex relationship in database using primary key, foreign key relationship. basic purpose is different. Each database use collect data and then extract the summary data and put in the Microsoft Excel or spreadsheet. And then we use it calculation and make a graph and make a model. Right? So two software is complement each other. Again, there is a two table. One is department, the other one is employee. You can identify primary key. DID is primary key, EID is primary key. Can you identify foreign key? Yeah, foreign key is here, right? Foreign key is other always field whose field is value is used as a other table's primary key. So other table's primary key. So DID is foreign key. Let's read this database again. Tom Buckley, which department Tom Buckley work for? Accounting, excellent. Accounting. How about Alex Irving? Alex Irving's department? MIS, thank you. So MIS. So this is database linked based on primary key, foreign key. Can you express this one? Can you show this one in the Excel table? Yes, you can make a more field here. Department name, location, number of employee here. Then you can make Excel table. Let's make an Excel table. So this is same information. The first one, Tom Buckley work in the accounting, Alex Irving in MIS. So if you use this Excel file or spreadsheet file, there is a three inefficiency happen. This one will appear in your exam, so pay attention. Three inefficiency. Three inefficiency. We call it anomaly. Three anomaly. Anomaly. We call it anomaly. So there are three anomaly will occur if you keep using spreadsheet. So I will show you the example. First example is called deletion anomaly. Let's assume Alex Irving quit the job. Alex Irving quit the job. Alex Irving quit the job. Then you will, here is Alex Irving. You will delete this record, right? Then you are actually deleting, we are losing MIS department information. If this employee happened to be the last person in the department, and if you delete this record because he quit the job, then actually you are losing department information about MIS. We call this one is deletion anomaly. Deletion anomaly. And next scenario is, let's assume we create a new department. For example, HR department. But we have not hired any employee yet. You cannot show this information. So this HR department information, because you have no employee, this is called insertion anomaly. If you make your spreadsheet, your data is based on employee, and if there is no employee, you cannot show there is a HR department. The last one is update anomaly. Update anomaly. Update anomaly is, for example, accounting phone number. Accounting phone number has changed. Then you have to change. In this example, you have to change accounting phone number 3 times. But in real companies, accounting, there are hundreds of accounting people, then you have to change hundreds times. That's inefficient. That's inefficient. That's we call it update anomaly. Look, summarize. If you're using spreadsheet to store data, there are 3 inefficiency happens, and deletion anomaly happen because if you delete last employee, like Alex or being quit the job, and or if you create new department but you have not hired any employee, then you cannot show HR department information. And if your accounting phone number change it, you have to change 3 times. This is inefficient. We call this is anomaly. Then let's go back to our database case and let's apply same scenario. So this is database. So first, Alex Irving quit the job. Then you delete this 11 record. Still, you can show MIS. There is MIS department. Without employee, you can show MIS department. So there is a no deletion anomaly happens. And case 2, scenario 2, you create HR department. Then you just add here department database part, number 5, and HR. So you can show HR, there is a HR department and information of HR department without adding new employee. That's so insertion anomaly does not happen in case of database. Last one is update anomaly. Accounting phone number changed. How many times do you have to change in database? In database, in this situation? Only once. So it's more efficient. So conclusion is, if your data grow, so more data is accumulate, then it's better use database. Then you can eliminate all the inefficiency using data. So in the exam, I will give you this kind of example and ask you explain 3 anomalies using this example. So I wrote down based on this example. I will change the example, then you should be able to explain in same logic. Let's take a 10 minutes break and let's resume at 5:35. I have a few chocolate left over. So if you want to take one each.
When you come back, when you're on. Where you going? Okay. One quick note. Well, hello, hello. Is everyone can't pick it up their property? Like I. You the one who has the programming software. I mean, you can find stuff online, or you can just download. But if you like, don't do that, it's not game right if you can. So we'll try and figure out a day that works best for everyone. I know people are gone for a week, so that's called.
I'm here all week.
I'm here. I'm here all week. Oh, the first weekend.
Yeah.
Oh, yeah. So we can find what's fast and I actually look at reading. If that works for her.
Online.
She's in Toronto.
Yeah, like I'm free from the 12th. until- Tuesday, Thursday, probably I have work on Friday, but I want to look in time with you guys, or everything that's going on.
Okay. So we'll. She. So we'll. Should. That's about.
So you could come up with a.
Exactly, so we'll take a look at fabrication. We'll take a look at fabrication.
Cool.
But
That makes sense. Did you just go on?
also I can take a look at those.
Oh, yeah.
This weekend, because after Thursday. Okay, so application, we'll take them, we'll look at it. Okay. Yes. They're both like 50% up. They're both for 10. Yeah. Okay. No, 15. Yeah. I said, Dairy Farmers in Ontario. Yeah, I've seen that. This was like an iconic guy. So, okay, I want you to no. I haven't seen it. Okay. No, it wasn't that. Okay. So the one, there's a bunch of kids in high school. Yeah. The basically the same as that. Yeah. The one that I wanted to do. Or it is scarring. This one has stuck with me for life. Yeah, we were talking about like adds a need for cognition and like this is happening. They're targeting. It is, and it sticks with you. You guys will never be able to forget about this. Yeah, that's good fun. I was always careful. I was always careful on water. I can tell you that. Yeah. You just grab the bowl and it all together. They had, what's the numbers? Degree? Yeah. Yeah, I think it was 3rd-degree burn. They had to wear like a constant for days. Oh yeah. He's lucky that it was only days. Was this the because when did we like down? It was quite bad. Did he get I don't know, man. I thought he said that it was 3rd, but did he get skin graft? No, he didn't have. I don't think he did. Is his arm okay? Yeah. Or is there still scar? I mean, kids feel so still. But it was like raw. Yeah, I can imagine.
Yeah, I was put hot boiling water on my hands here, my skin turned gray, fell off afterwards, like it was disgusting.
Sloughed off, degraded.
Yeah.
I have like little birds and I will have like a barn say by accident. And then one time. That was when I was great. And so we had to protect it from the and we knew that but then we were and I missed the first edge and on the second edge, so in the box, like God, it's so but it's not gonna want to have I actually can't drop it. And my friend was basically and my friends were too busy laughing for everything like they were acting lying, over laughing. I'm well not fucking
You have Armstrong, so you can it. I was trying to figure out how, like.
No, it was
what we
not.
find
It is not like that.
Like, what's up your phone? And while she was standing.
She was standing in front.
Yeah, we had like pallets and stuff. All this fire.
Nobody got hurt.
Her phone just fell.
RIP that phone.
She got her brother actually.
Okay, shall I start now? Let's discuss about how to design database. How to design database. So this will discuss entity relationship model and step in database development, and we'll discuss conceptual model and logical design. So how to design database or how to design information system or software? First, let's assume you are making a database for accounting department. Accounting department, you are making database for accounting department. First step is you need to visit accounting department and ask each step in the accounting department and check what are their data requirements. What data do you need? Ask them and collect all the data requirements. Sometimes those accounting staff has no idea. I have no idea. Then ask them, show me your report to the manager. If you see the report, then you can tell what data they need or they use. So that's the first step. Go and collect end user requirement. This is first step. Then second step is convert this one as a conceptual model. Conceptual model. And then third step is convert this conceptual model to logical model. And next step is based on all the logical database you designed and convert it as a physical database design. But this number 4 is usually done by database administrator. So you do not have to worry about this part. So we will discuss this 2 and 3. 2 is making conceptual model. This process is called conceptual modeling. And third part is logical, we call it logical modeling. So all the software project is designed by this way. First, collect user requirement. What do you want? And then convert it to as a conceptual model. Then later convert it to technical design. So here you wonder what is the conceptual model. So I will explain that one first and then explain why we need conceptual model. So first, conceptual model. Here, conceptual means abstract level or high level. Model means representation of real world. So if you add these two definitions, conceptual model means abstract level representation of real world. So let me give you an example. So let's assume you are driving from UMB to Hilton Hotel at Uptown. What information do you need from real world? Yeah, you need to know the road name. And if there is a cross, which turn you go, right turn or go straight, left turn. That's all you need to go to the Hilton Hotel, right? Do you need any good restaurant information along the way? It's nice to have and it's real world information, but it's not necessary, not required information to drive to the Hilton Hotel. So there are lots of real world information, but some information is necessary for our purpose. In our purpose, design the database. Other information is not necessary for design database. So conceptual model is extracts information required design database from real world and eliminate or hide all other real world information so that it can easy to understand, right? Increase understandability. Hide all the unnecessary information and extract only relevant information to design database. That's the conceptual model. So it's high level or abstract level, hide all the complexity and extract only the information which is necessary to design database. And here is another exam question. So I understand the conceptual model is kind of extracting real-world information and represent to design the database, or extracting information to design database from real world. Then why do we need this conceptual model? Why don't we just skip conceptual model and directly design database from the user view? That's the question. Then your answer should be these three. 1, 2, 3. We should answer this part. So let me ask a question. Do you anybody who can speak language which your classmate do not understand? Anybody can speak language which your classmate do not understand? What language?
Cantonese.
Cantonese. Can you understand Cantonese? Yeah, then no. They understand. Anybody can speak language which nobody understand in this class?
More.
Yeah.
We've got a little bit of German. We should recognize these in English.
Yeah, in German. Okay, German. Anybody understand German? Okay, yeah, please stand up. Thank you. Can you say something in German?
Like, ich spreche ein bisschen Deutsch. Guten Morgen. Or guten Abend.
Yeah. I don't understand, but I think you are saying this at good night. Right? Yeah,
Good afternoon.
Good afternoon. Right? Can you speak a little bit more difficult conversation?
Guten Abend, mein Name ist Jared. Ich bin 23 von year alt.
Great. Anybody understand?
Jared.
Anybody understand Jerry is talking about? No, I nobody understood. Thank you so much. Can you translate in English?
It's just, good afternoon, my name is Jared. I'm 27 years old.
Oh, thank you, thank you. Yeah, wonderful point. Thank you very much. You see, when Jerry talked in German, nobody understood what he was talking, right? This thing happened in every company. Every company, but it means when IT people talk about the database requirements, IT people has very difficult to understand what accounting steps are talking about, because accounting step use a lot of accounting jargon terminology, which does not make sense to IT people, right? Same thing happened in the accounting people as well. Accounting people cannot understand what IT guys are talking about, because IT guys talk about a lot of technology things. So there is a communication barrier, no common. So they have difficulty to communicate each other. Basically, accounting group outsource making database work to IT group, but if they do not communicate well, so accounting asks making A, but IT group making B, then that's the disaster. So we need some tool to make it clear. So we need common language. Everybody understand. So meaning is clear. Stand that kind of common language. That's conceptual model. So conceptual model work as a common language between IT department and end user department. So they both understand clearly without multiple interpretation. And second reason is, this is first reason. Second reason why do we need conceptual model is accounting department also work to IT group, then they have to verify their requirement is accurately described. So verify accuracy of user requirement by user. So confirm, this is what I want. And also if you integrate all the user data or user requirement, then you can tell there is inconsistency. So you can create, eliminate those errors, because accounting staff also do not understand their procedure, sometimes misunderstood their procedure, right? So we need, if you draw conceptual model and integrate all the accounting steps data requirement, then you can identify error, and also you can verify, confirm, oh, this is our accounting group want. Make this database. So confirm, verify accuracy of user requirement by user. And third one is logical independence. This is just technical one. So at least you need to mention first two in the exam. And third one is logical independence, which means from same conceptual model, you can convert it to hierarchical database, relational database, and object-oriented database, right? So for example, you are using hierarchical database, and now you are going to change the database to relational database. Then you do not have to go back to user. You just start from same conceptual model, convert it to relational database. That's the logical independence. That's the reason why we create conceptual model. My question is, one of the conceptual model is ER diagram. So question will be, why do we need ER diagram? Why don't we just convert user view to logical database design? My question, then your answer should be, because there is a communication barrier, so we need common language between IT group and end user. And end user needs to verify their requirement is accurately described. That's two reasons why do we need conceptual. So when you make a design system or software, we always do first collect user requirement and change it to conceptual model and verify whether is it what you wanted. So in case of conceptual model, we all use many graphical notation because it gives clear interpretation. To be a conceptual model, it should give a single interpretation. You might wonder, look, we all understand English. So why don't you use English as a conceptual model? But to be a conceptual model, it should give single interpretation. But unfortunately, English give many multiple interpretation. See this example. Napoleon is strong. What does this mean? Napoleon is strong. Napoleon, if you know the European history, Napoleon is hero who almost conquered every territory of Europe. Right? That's one interpretation. And like me, I like liquor. Napoleon is brandy, one of the fine quality brandy. So it's one of the liquor, and this Napoleon is strong. So you can interpret two different ways. So this is not good for conceptual model. You might wonder, how about using gesture? Gesture like this is, I like you. But I found gesture also give multiple interpretation. When I arrived to Canada for the first time, I saw many women use this gesture. Honey, come here, come here. Honey, come here, this way or this way. Can you see? Come here, come here. I was surprised. In the same situation in South Korea, I'm originally from South Korea 26 years ago. We use this gesture, honey, come here. Can you see the difference? Canada is this way. This way is the Korean style. This is Canadian style. And we use this gesture as well, but for special occasion. We use this gesture only counterpart is dog or cat. So if my wife say, honey, come here means it imply I'm dog or cat. Insult. So what I'm trying to say is gesture is not good for conceptual model because it gives multiple interpretation. So that's the reason why we use many graphical notation to give single interpretation. So let's talk about the step of database development. First one is you make a conceptual model and then make a logical database design. And the other one is covered by IT group. So in case of conceptual model, there are many methods. But today we will discuss entity relationship diagram, which is one of the conceptual model, which give you a clear interpretation. Anybody is familiar with entity relationship diagram or EL diagram? Please raise your hand. Nobody? Okay, then it's good chance to learn a little bit of EL diagram. And in case of logical database design, as I told before, same conceptual model can be converted to many different database, but we'll focus on just converting it relational database. So let's talk about EL diagram, which is conceptual model to design database. So extract information from the database. To make a conceptual model, read the end user requirement or what accounting step says, and identify 4 things. First, find entity. Second, identify relationship. Third, identify attribute. 4, identify cardinality. Then it's end of the EL diagram. EL diagram or entity relationship diagram. So entity is represented with box, like in this rectangle, and enter the entity name. So this is a kind of rule. So you cannot violate rule. You cannot use over to show entity. Rectangular is for entity. And relationship is represented with the diamond symbol and line. Diamond symbol and line. And attribute is represented with oval or bubble. And cardinality is represented with the one case it's vertical bar, and many cases greater than or less than. So we'll figure out this one by one. First, entity. Once you read the end user data requirement, find the entity. Entity is, here is entity definition. Entity is a person, place, event, thing, which you intend to collect data. So in other words, anything, if you want to collect data about that part, that is the entity. So here is a university. Entity candidate can be student, professor, course, class, department, even this chair, this computer, all can be entity. And which one is entity, which one is not entity, depends on whether you intend to collect data about student, then student become an entity. But if you have no plan to intend to collect data about professor, then professor is not an entity. So entity is actually group name. So another name of entity is entity class, entity set, entity type. For example, let's assume student is entity and it's a group name. Group of student is called student. Then how about you? Each of you are called entity instance, one occurrence of entity class. So you are entity instance. I am a professor, so I'm an instance of professor entity. So identify entity first, then identify attribute. Attribute is just property of or characteristic of each entity. For example, let's assume student is entity, then student characteristic like student number, name, GPA, date of birth. These can be candidate for attribute, and which one can be an attribute? Oh, same rule, right? If you intend to collect about student number, then student number become an entity. If you want to collect name, name can be an attribute. But if you have no plan to collect GPA, then GPA is not an attribute. So collect property. And one thing is, if one attribute is a primary key, then you should underline these attributes. In case of student number is primary key, so underline it. Okay. Once you identify attribute and entity, so here is a, let's assume there is a two entity, teacher and student, and teacher has two attributes, ID and name. Then you have to connect this one belongs to teacher, and student has two attributes, student name and number. And don't forget, underline if it is used as a primary key. So ID is used as a teacher's primary key. SNAM is used. So that's the reason why we underline it. So we identify two things, and next one is relationship. Relationship is association between entity. And one thing you have to remember is trying, in case of relationship, always trying to use verb. Do not use noun. Noun is bad. If you use noun, it gives multiple interpretations. So always trying to use verb which describe a relationship between two entities. So now, last one, fourth one is cardinality. Cardinality is, the definition is here. Definition is number of instances of one entity that can or must be associated with each entity of another entity. I tried to read this one so many times, but I was not able to understand what it means. So I decided to teach you by giving you example. Anyway, there are three types of cardinality. And cardinality is one. In case of one, using vertical line is one. And in case of many, is greater than or less than symbol. So let's practice this one. So in case of right side many, use this less than symbol or increase the branch here. This is many sign. If it is in the right side, then use this many sign. It's the greater than symbol. So same as this is same many. So another way you see is increase branch. 3, that is the many sign. But if you wanna show one, then make a vertical line. This is the one sign, okay? Now let's try to make a EL diagram. So here is before there is a two entity, teacher and student, and they have two attributes. Each one has two attributes. Now relationship. Teacher teach student. Important thing is teacher, it should be verb inside of this relationship. And then let's have a cardinality. So if this is many, so one teacher can have many students, and each student belongs to one teacher. This is one. This is example of EL diagram. Now let's focus on cardinality practice. So if you turn the page, 1, 2, 3, 4, then you will see this cardinality practice. Cardinality practice part. And trying to identify entity and relationship and cardinality. And you do not have to show attributes. So let's do it together. First few, then you can do it by yourself. So let me download first. So this part is most important part. Not most important, but once you know, it's simple, but it's very difficult if you miss this part. So let me show you how to identify cardinality. There are two entities, natural mom and her children. So to identify cardinality, you always start from left side and ask this question. For single mom, for one mom, how many children can be related? For one natural mom, how many children is related? So mom can have 0 child, 1 child, 2 children, 3 children, potentially many. Then we will call this is many. So that's the reason why create more branch. So this is many sign. Now change your anchor to the right side. To the right side and ask this question. For one child, how many natural mom can be related? Only one, right? Each child belongs to only one natural mom. So we make one sign here. So we call it one too many. This is cardinality. So let's do one more time. Exercise number 1. So let's go. How husband and wife. So entity is husband. It should be rectangular. Husband. And another entity is wife. You have to write full name. I'm using mouse, so it's difficult, so I'm just make it small. And there are two entities, and what's the relationship between husband and wife? Husband love wife, husband like wife, husband respect wife, husband admire wife, husband is scared of wife. Whatever relationship, you should add verb, not noun, to increase clear interpretation. So husband, like I would say, admire, but let's say love wife. So we just finished the identify entity and relationship. Now let's identify cardinality. Cardinality. First, always start from left side. For one husband, how many wife can be related? Depending on country, there are many, but you always do not assume your country or your culture. Go back to your end user and ask them. And this time, their assumption, here is the assumption. One husband has only one wife. Yeah. So for one husband, we can only relate it only one wife. Then in the wife side, give vertical bar. This is say 1. Now change your anchor to the right side. For one wife, how many husbands can be related? I know some country, one wife can have many husbands, but that's your common sense. Do not depend on your common sense. Ask to accounting department what's their requirement, right? In here, their requirement is one vice versa. That means one wife can has only one wife. So we draw this bar, and this is 1-to-1 relationship. Now let's do it. Let me do one more so you can do rest. Customer and order, customer place order, right? So let's try, there are two entities, customer and order. And the relationship is customer place order, customer has order. Important part is it should be verb. And now let's check the cardinality. Cardinality. For one customer, how many order can be related? Multiple, right? Customer can place many order right here. So make show many sign. Now change your anchor to the right side. For each order, how many customer can be related? Only one, right? Each order belongs to just one customer. So choose vertical bar. Okay, now let's do 3 and 4 and 5. And show me green button if you complete. You can discuss with your group and share your results with your group as well.
That makes sense.
Yes.
Yeah.
Participants clubs, and so it's looking at these two as, yeah, looking at these two as. That is it. And the last one is many to one. We only have one title.
Once you compare your results with your neighbor students of your group. Okay, let's do it together. See, so now student and club. So there is a student. You can put student first or club first. It does not matter. And club, there is the two entity. We omit all the attribute, but you need show attributes later. But this one is practice cardinality. We omit this one. And club. So what's the relationship verb? Student join a club or has a club. It does not matter as long as it's verb. Now let's check cardinality. For each student, how many club can be related? Many, right? Each student can join many clubs, so it's many. So increase branch, number of branch, and now change the anchor to the right side. For each club, how many students can be related? Many, right? So it's many to many relations. Any question for number 3? Okay, then let's go to the number 4. Number 4, order and order details. So let's do entity order and order detail. Order detail. And diamond symbol and connect each other. And relationship with order has order detail, or order include order detail. Now let's check the cardinality. For single order, how many order detail can be related? Many, right? So order has many detail. Based on assumption, this increase many. And now let's change the anchor to the right side. Order in case of one order detail, how many order is related? Each order detail belongs to specific order, right? So it's 1. Any question for this part? Okay, then let's move on to next one. And title and employee. There is a title. And employee. What's the relationship? Title is given to kind of thing. Is given, forwarded to, given to employee. Now let's check the cardinality. So for single title, how many employee is related? Many employee can have same title, so single title can have many, so it's many. Increase number of branch. Now let's change the anchor. For one employee, how many title can be related? An employee has only one title, so it's one. So it's one-to-many relationship. Any question for cardinality? Now you identify cardinality, right? So basically, EL diagram is showing 4. Actually, in industry, a few more, but in this class, that's enough. Just showing 4. Showing 4. They are these things. So first, entity, and then show relationship, and we did not practice but show attribute using overall, and then show cardinality. That's end of EL diagram. So let's practice this from place parents directory. Here is the user requirement. End user says this. So identify entity, identify attribute, identify relationship, and cardinality. So create a EL diagram. So there is the paper material. You can find the place description, so you can draw this one and take a picture of your finding. Oh, so first of all, submit your first assignment, the one page of the cardinality practice. There is a one assignment folder, so submit this one, sorry. Submit this one page cardinality practice. Take a picture and submit. If you are in person, attending this class in person, then you can get Choco Point. This is used as your attendance. So if you take this course via Zoom remotely, then you are not supposed to claim Choco Point, but submit as your attendance. Yeah, after submit, then complete this example one, place parent directory. So this is user requirement and create a EL diagram. Entity relationship diagram, meaning is identify entity, add attribute, and add relationship and add cardinality. What entity did you find? Student is entity and doctor is entity. Yeah, doctor and student. While they mentioned director is not entity because they did not mention they want to collect data about director. They only said they want to collect data about doctor and student. So these two are entity. So first of all, you have to identify entity, right? So there are two entities. One is doctor. The other one is student or children. And let's add the relationship. Relationship. Relationship is doctor treats student or doctor has student. As long as it's both, that's okay. Yeah, student has doctor is okay. You can this change the sequence, right? Student has doctor, that's okay. So let's do that way. Now let's add attribute. So attribute student has how many student attributes? Student number, name, age, 3 attribute. So first attribute is student number, student number, and the other attribute is student name, and another attribute is age, and connected over here. Doctor has doctor's ID. As an attribute, and another attribute is doctor, she wants to name and telephone number. Name, name, and another attribute is telephone number. Telephone number. So we just made the entity, relationship, and attribute. I forgot to underline it. So primary key, student number is primary key, so I have to underline it. And in case of doctor, ID is primary key, so you have to underline it. Now let's add cardinality. For one student, how many doctor can be related? Only one? Sorry. Sorry, let me repeat. So one student can have only one doctor, right? Each student will have only one doctor. So for one student have only one doctor. So we just made this wrong bar. And let's change the anchor to the right side. For one doctor, how many students can be related? Many, right? So because the scenario or requirement said doctor may have more than one child. So we made many. So this mark, increasing branch, is many sign. So this is the answer. Okay, so this is the answer. Any question? So if you take a photo of your output and upload it in the D12 as another evidence of attendance, if you're in class, you can claim 1 choco point for this. If you are in the remote, in the take class Zoom, you cannot claim choco point, but please submit as an attendance. So this time from place parents directory. Directory. So now we just learned the EL diagram. So EL diagram. Now that's the conceptual model. So you finished the conceptual model. Next step is converting it to the logical table design. Logical table design. Logical table design is quite mechanical. But first of all, let's talk about table notation. Table notation. To show table design, it's simply in the line, write the table name and open the parentheses and write all the attribute or field name and close it. Close it. And if that field is used as the primary key, use continuous underline. If that field is used as a foreign key, use dotted underline. That's the notation. So let me show you one example of table design. For example, there is a two table, department and employee, and here is a DID is primary key, EID is primary key, DID is foreign key. To show this one, our design is write the table name, department, and then write all the field name, DID, name, location, employee, phone, you separate by comma. Then add the primary key using underline, showing this is underline. So DID, EID. And if there is a foreign key, DID in the employee table is foreign key, use dotted underline. And show this foreign key is matched with this primary key using arrow, starting from foreign. That's the notation. That's the table design notation. So this is table design, or this is we call the logical table design. So it's yeah, industry use different way, but in this class, please stick to this way because my marker only know this way. Now, then there are three. Let me show you. Let me give you the rule. The converting it, once you draw real diagram, converting it to logical design is quite mechanical. So you find this rule and apply rule, and it will work. So 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4. Mechanical, if you're in the remote, and this is in the, oh, thank you. It's the 4-5 rules convert ER to table design. So apply this rule, then you will design the relational table design. So let's do it one by one. First one is one-to-one binary relationship. How do I know it's one-to-one? Because the cardinality shows 1 to 1, right? In this case, rule says first each entity become a table. Each entity, so entity A, entity name become a table name. Entity B, and entity become a table. Entity B become another table. Because rule says, rule number 1, entity become a table, right? Can you see this rule? Rule number 2, attribute become a field of the table. So entity A has two fields, A key and A1. So let's move this one, A key and A1. Sorry. And so B1 as well. So B key, move B key and B1. That's step 2. And step 3, put foreign key in case of one-to-one either side. Either side means you can put foreign key upper side or lower side. So let's put in the upper side. Let's put foreign key in the upper side. Foreign key is always other table's primary key, right? Foreign key is other table's primary key. So if you put upper side, foreign key means this other table's primary key should be inserted to entity A. So as a result, B key is inserted as a foreign key. Does it make sense to you? Foreign key is always other table's primary key. So don't forget underline primary key using continuous line and dotted underline using foreign key. That's one answer. And because rule says it's either means you can do either way. So put foreign key in the entity B, foreign key to table B, then what should be entered in the foreign key in the entity B? Foreign key is other table's primary key. So A key should be entered as a foreign key in this table. So second solution can be this way. So A key is inserted as entity B. So now let's do exercise. If you turn the page, there is a one-to-one binary relationship and trying to complete example 1. So here is a one-to-one. Employee manage each one department. Each department belongs to one managed by one employee. Then trying to convert this ER table as a relational table design. Then rule number 1 is each entity become a table. So employee become a table. And department become a table. And rule number 2, each attribute become a field of each table. So upper part is EID, comma ENAME, comma address. Address. And department has 3 attributes. So department ID, comma DPT name, comma location. So this is rule number 2, right? Rule number 3 is add a foreign key either side. So we can do any side, but let's add employee side. Then what should be added in the employee side? Department ID, yes. Foreign key is always other tables primary key. So you have to add department ID. Now let's underline for primary key using continuous underline. Department tables, primary key, department ID. And foreign key, department ID, foreign key in the employee is dotted on the line. And make an arrow starting from foreign to primary key. Foreign to primary. Any question for the one-to-one table conversion? No. So let's move on to next step. Next one is one-to-many binary relationship. One-to-many binary relationship is same rule as one-to-one. Last step is different. Put foreign key to last step is foreign key to many side. Which one is many side? Entity A or entity B? B is many sides, so you have to put foreign key to entity B. As a result, other table's primary key, A key is inserted as a foreign key. So let's do this one with the example. So turn the page. One-to-many binary. This one, and trying to do it by yourself. Design it. So first rule, each entity become a table. So two table, employee, table, and department table. And second rule is each attribute become an attribute of each table. So EID, e-name, address. And in case of department, has three attributes: DPTID, DPT name, location. So this is rule number 2. Rule number 3, add the foreign key to many side. Which one is many side? Employee side. So employee side has a foreign key. So foreign key means other table's primary key. So other table's primary key is department ID, right? So department ID should be inserted.
The other way around. Yeah.
Which one?
It's good, just because they're switched.
Oh, yeah, I see.
Do you have chocolate?
Hmm?
Chocolate.
So now, so then let's don't forget to underline for primary key using continuous line and dotted underline for foreign key. And make an arrow starting from foreign to primary. This is complete table design. Complete table design. Any question for one-to-many? Okay, let's move on to next one then. Many-to-many. Many-to-many is a little complicated. Rule, see the rule. Each entity become a table. That's same. that's the same. But each attribute become a field of table. So A key, A1, that's the same. But number 3 is quite complicated. Many-to-many case, create another table. So this diamond symbol become another table. So in case of many-to-many, you have to create 3 tables. 3 table. And also this time put foreign key to this relationship table, this diamond symbol table. So always foreign key is other table's primary key. So other table is, there are 2 other tables. So A key is inserted as a foreign key. B key is inserted as a foreign key. And last one is this, combine these 2 foreign key, combine these 2 foreign key as a primary key of this relationship table. So remember this shape. Inside there is a relationship table, and also find this primary key, foreign key part. So pay attention, this foreign key is dotted line, just cover one field, A key, and dotted for just cover B key. But the primary is combined primary key, so you have long continuous line. So let's do this many-to-many. So many-to-many, and do it, apply it, and take a photo and submit this one to claim 1 choco points. So let's do the many-to-many. So first rule, employee table. Entity become a table. So employee table. And there is a project, make room because there is a work for project table. And we know there is another table, work for. So there are 3 tables in case of many-to-many. And second rule, attribute become an attribute. So EID, e-name, address, and work for has a field. So start date. You can put start date at the end or in the beginning. It's up to you. Project has a project ID. Project name. Location. And add the foreign key to the work for table. So the relationship table. So we have to add 2 foreign key. Foreign key is other tables primary key, EID. I will put this one in the beginning. EID. You can put start date in the beginning as well. Either one is okay. Project ID. We just customarily put primary key in the beginning. So and now let's put underline, primary key underline, primary key underline, and there is a primary key long underline which cover both EID and project ID. And foreign key, EID is foreign key, so dotted underline, which cover just one field, and another dotted underline which cover just project ID, and put arrow which shows corresponding one. This is answer. So make many-to-many part by yourself and take a photo and submit to claim 1 choco point. Let me create a choco folder. I think. Third folder. I think. I will change this folder name. Too many table design. And I will hide the other one because so
Okay, well, I did.
you are supposed to submit 3 things today, and each one attached to 1 choco point. And I think you are not ready to solve the assignment 5, so I will post assignment 5 1 week later, and we will practice a little more in the next class. So yeah, that's all for today. So if you have any question, I will help you. No, just one. It's many to many.
The order doesn't matter, right? Like.
Yeah, you can put start date in the beginning.
But for this one, doesn't matter.
But it does not matter.
Like you put this one or this one
But
after.
our custom is put primary key first,
Yeah,
then
yeah,
other pages.
okay. Thanks.
Thank you. Just one photo comment. Thank you very much. Thank you. See you guys.
Oh, that's.
This.